All right, we are back, CSTN 283, March 29th. Let me get back to our PowerPoint, which you can see. I cannot see it at the moment, so let me find it. All right, here we go. I am back in business. So we just talked about the basic audit process and components of it, and now we're just going to go through some tactics and strategies and some of the typical things that you can do. And like I said, there's not necessarily the playbook that you can run through on each and every house. They're all slightly different depending on when they were built, how they were built, how much maintenance they've had or have not had. But these are just some of the very basic strategies. So attic air sealing, and this is probably one of the easiest places that you can get to. And this is just a picture of some spray foam up in the attic. And you can see they pulled back the insulation to be able to get to these areas where this is on the smaller picture up here on the right is where a partition wall from down below is connecting to the ceiling joist, and obviously there was no air sealing in there. You can see on the larger picture back in the rafter bays, they've added some solid foam baffle and then some baffle up above to actually get some airflow up in there and control the airflow so it's not blowing the insulation around. That's something you may or may not see up in that attic. I don't know. So something to look at when you get up there. But some of the other basic areas, these are all in your book. These are all in the Energy Out West guide with details and pictures, so you should be able to find these and inspect them. But anywhere you've got a chimney or a furnace flue, hot water flue going up through the attic, it should be sealed off. You need to be careful that depending on the type of flue, if it's not an insulated three-wall pipe, it's got to have non-combustibles on it, so you got to be careful. You can't just spray foam it in. You'll have to look at options for fire caulking. Sometimes, I've seen too where they'll run a furnace flue or a hot water flue up through the sheetrock in the mechanical room, and the flue might only be 6 inches around, and they'll cut a 12-inch hole and just leave it. So you may have to get some sheet metal around that and then fire caulk it in. What's that?
If the vent is PVC, then that means...
If the vent is PVC, then yes, it's going to be, you'll be able to put right up next to it, right up the spray foam. Any sidewalls or knee walls or soffitted area, and you're going to have a couple of those up in the attic that we're looking at, because if you remember, it was flat ceiling in the center, and then there was some scissor trusses on both the east and the west ends of the house, so you probably have some little knee walls up there to check out. All the penetrations, any connections that happen up there. If it's not a perfectly flat ceiling, if it's got a partition wall from downstairs that connects into it, if it's got roof framing tying into it, the outside wall, that pocket door frame was an interesting one, and unfortunately we didn't get video of that, but I bet if we put the thermal imagery camera on there, we would have seen a pretty big differential. So that'll be one to check out. Drop ceilings, any place porch roofs tie in, attic stairs or the attic hatch. That was a kind of a no-brainer. I'll tell you all, since you're all here, if anybody misses the attic hatch, I'll dock you on your group project. I'm not even sure there was insulation. I think the attic hatch was just a half-inch sheet of drywall, and no board or anything. no foam, no gasket, no nothing. So, light fixtures, anything that penetrates that building envelope in any connection. And this is just a sample list. Same thing on the exterior walls. All of the windows and doors, and you'll have to explore some options. There's a lot of different weather strippings and caulking that you can do. It is difficult getting to some of it, especially in the finished areas, but we'll take a look. Top and bottom plates, the switches, the boxes, the electrical outlets, any and all penetrations. We found a bunch of penetrations that were completely left open, not sealed. Tubs and showers on exterior walls, and the challenge with that is if the tub and a shower is set up on an exterior wall, it can be pretty difficult to get to it. So any walls between the house and the garage, most of the time, standard construction practices up until about, I think 6 years ago, didn't require any air barrier between the house and the garage, so most of the time they're completely connected, and they communicate pretty significantly, which is not only an energy loss, but you've got, most of the time in the garage is where you've got all the pesticides and the paints and the varnishes, and then you drive a car in and out, so that's always a big one. All of your registers, your duct boots where your heating registers come up through the floor, can be a big deal if some of the ductwork is located outside of the conditioned space. It's not as critical. A lot of times, though, you'll see, especially in cooling climates, all the air conditioner ducts are in the ceiling. Inversely, we want to heat from the ground up because we like to take advantage of that natural stack effect and let our heat go up through the building. Air conditioning is usually delivered up high, so it can do just the opposite and drop. So a lot of times in houses in cooling climates, all of the ductwork is going to be in the ceiling, and a lot of times it's just not sealed. The ductwork is completely uninsulated in the attic. None of the boots are sealed, so they can be a pretty big energy loser. And then just a couple strategies, and I know you guys are going to look at these and research them and come up with some other ideas as well. But some windows and doors, basic caulking, there's commercially available weather stripping in a lot of different sizes and a lot of different applications. Anybody seen these yet in your group project homework? Yeah. We found a fair number of outlets that were significantly communicating to the outside. There was quite a bit of air leakage coming in through some of them. So whether it's caulking or gaskets or other ways that we can inexpensively seal them up, we can get a lot of benefit out of those. Plumbing penetrations, top and bottom plates, again, anywhere that you've got a hole in the envelope, and it's obvious if it's a plumbing penetration on an exterior wall, then certainly it can be communicating directly to the outside. We saw a couple spots in there where it was interesting, even on an interior wall, and if you remember, we're talking about it, once you get a hole into a wall cavity, it's not necessarily just communicating directly outside of that hole. That cavity itself becomes the conduit for air leakage. We saw that a little bit with some of the outlets and the switch covers. Looking for inconsistencies, incomplete areas, poor installation of insulation in the thermal envelope, and these are just a couple examples of exactly what can happen if we have it. So, I think we have a couple areas in our house to look for, but any place that you've got insulation that's either not installed properly. So here you see they didn't cut the insulation around the outlet box. They just went around it, so both above and below the outlet, you've got these huge areas with absolutely no insulation. So what's going to happen when they put sheetrock on there? It's going to have no insulation for as long as that sheetrock is on there. And then right next to it is just one where they've taken the insulation and they've jammed it behind the box. In thinking back to that whole point of what fibrous insulation does and how it gets its resistance, is having that airspace in there, those tiny micropores in there that are slowing down the heat transmission. So if you compress them, it just becomes a much more solid surface and significantly loses its R value. Also, looking for areas where the insulation is either degraded to the point, and here the picture on the bottom left, you can see that it did have insulation in there, but it either fell out, got ripped out, got wet, and sagged out. And then the picture on the top, you've got some loose fill insulation, and you've got a drain pipe, a plumbing drain going, it looks like from one side of the crawl space to the other, and maybe one side's not insulated, but you've got enough air moving through there that it's pushed that insulation completely out of the way, and it's pretty ineffective. So how do we fix those things? Sometimes it's just a matter of adding more insulation. Stopping the flow of air is probably just as critical. So there's a couple examples of using basic blanket insulation, some spray foam, some hard foam insulation, and sometimes it's just bringing it up to the proper depth that it needs to be. Over the course of time, that loose fill insulation gets blown around, it can settle. So while it may have been installed at 14 inches, which was getting the proper R38, over the course of time, you get people who go up into their attic, they store a bunch of stuff in there, they compress all the insulation, they move it around, it gets blown around. So take a look at that. Depending on the situation and budget and what's there, a couple other ways to upgrade. If you can get some type of loose fill blown in, there's a few methods to do it here, just showing pulling off a row or two of siding, coring into each one of those bays, and filling those cavities with either a dense packed cellulose or some other type of loose fill insulation. Great opportunity if you're doing a re-siding or at least some exterior work on it, but it can be kind of tough. You don't necessarily always know what's inside those building cavities, so it's not always possible to completely fill them. It's actually another great opportunity to use the thermal imagery camera, because you can kind of see if you've got what you think is a bay, but it turns out to be 6 2x4s stacked and nailed together, you're going to have a hard time drilling into it, coring into it, and blowing insulation. So it's good to know that ahead of time. Also look at proper connection and proper insulation of any of the moisture control measures. So we did discuss at great lengths about what happens to moisture vapor when it reaches a certain temperature and hits the dew point and condenses. These are actual pictures of fairly new houses, actually, within the last 15 years, where the ventilation is running straight into the attic. The one on the left, I think they just forgot to hook those up. It looks like they were going to probably put them all together in one box and run one turtle vent on the roof and be done with it, but they forgot. And so you had 3 bathrooms that were all venting their really warm, moist air directly into the attic. and you can see on the right-hand, the one on the right-hand side, that's heavy frost on all the white part is heavy frost. The only reason that center section is not frosted over is because it's got really nice 70-degree air blasting on it, which is why the black mold is on it. So again, take a look at that. It's another, and these are all things that are in your book. These are all fairly prescriptive places to look. They're not going to be the only places, but certainly a good start. So again, making sure that the venting is properly insulated, properly vented. Then we talked about equipment efficiency and how it's distributed. Sometimes the equipment can be replaced, and that is going to be the best bang for your buck. Again, and they'll talk about a little bit in efficiency measures. It's going to be pretty budget dependent. So changing out the equipment isn't necessarily always going to fit the budget. It's also not necessarily going to be the highest return on investment for an efficiency measure. Sometimes it is the distribution. The picture on the left is just, this is a wall we opened up a number of years ago, and they were definitely, and you were doing a fairly substantial remodel, but they had definitely been complaining that the whole west portion of their house was far colder, and they thought primarily it was much colder than the other part of the house because it didn't have as much insulation, but in fact it turned out to be much colder because it just wasn't getting any heat. The ductwork wasn't connected. And then you can see, again, here's one with the leaky ductwork, and this is one that's in an attic. And so this is in an uninsulated, unheated attic. So that ductwork was leaking air directly out into the unconditioned space. There's a couple different methods, whether it's tape or mastic. And again, you have to evaluate whether it's the most cost-effective and the highest return to seal the ductwork. We had some conversations about that while we were there. And unless there's something in the attic that we didn't see, all the ductwork in that house is in the conditioned space. So would it make sense to go in and this on the right is aero sealing. For a house that size would probably cost about $700 or $800 to go in and seal up all the ductwork. Is that going to be the best use of our budget? Probably not. But in some instances, if you've got all the ductwork outside the conditioned space, or if it's in a spot where you can't get to it and you can't easily fix it, that certainly can be an option.
So what are they blowing into the ductwork that's going to seal it from the inside? So almost like slime for a tire?
It's similar to that. It's an aerosol system.
Yeah.
And they close off the air handler and close off all of the vents, and they pressurize and charge the system, and then I'm trying to remember what the chemical is, but it's just a reaction then that with the kind of a static reaction, and it'll fill a hole they claim about the size of a dime.
Oh, wow.
So it can do a pretty significant job. One of the things we didn't talk about too much, and it's not directly, it does have efficiency concerns, but it's not usually the first line of attack that we take when we're talking about energy efficiency. Water conservation and water efficiency can also be a part of an audit. If you're using an excessive amount of water, whether it's through leakage or through poor distribution, that also means that you're heating more water than you need to. So indirectly, it can be a fairly significant efficiency measure. Replacing fixtures with low flow, and currently low flow fixtures are fairly ubiquitous. They're easy to get a hold of, and again, you have to evaluate what the overall objective of the weatherization plan is, and if that's your best cost measure. So sometimes replacing the hot water equipment, relocating it, and I've told this story a million times, but that's one of the things that I've got to do in my house, because my hot water heater is completely on the wrong side of my house from the master bathroom and the kitchen, and so I have to turn on my shower and then go brush my teeth, and then if I'm lucky, by the time I'm done brushing my teeth, I have hot water. But if you're doing a weatherization or a whole house energy retrofit, and if you are already replacing the hot water heating equipment, looking at options to maybe putting it in a more central location, looking at things like plumbing manifolds where you're reducing the line size so you don't have as much hot water standby loss. And then looking at the rest of the dishwasher, washing machine, the rest of the efficiency and the water factor of that kind of equipment. And then the last part about it, and again, it depends on the scale of the energy retrofit and the weatherization, and if it fits in the budget, adding renewable energy, or especially if you're doing some remodeling and renovation work at the same time, at least adding the potential. So you may not be adding the PV at that current point in time, but running the conduit down to the electrical panel where the inverter will be and up to the section on the roof where the PV may be, fairly inexpensive. But once you close that up, and this is from a small addition. The picture on the right is just from a small addition, and that was all going to get insulated and sheetrocked. And so putting the conduit in and at least running the wires up to that area in the roof was fairly insignificant, just a couple $100. If they decided 2 years down the road, after it was all insulated and sheetrocked, and wanted to put PV in then, it would have been significantly more expensive to do it. So those are just, and again, there's a bunch more in both the Krieger book and in the Energy Out West. You can go through there and get a ton more strategies. That was just a start. And then the last part of it is sometimes always the most difficult, and this depends on what the objective of the project is. And so how do we evaluate all of the conservation measures, the energy conservation measures that we're going to put in? And like a lot of answers, it really depends. And this is going to depend on the homeowner and what their objective is. It's going to depend on your budget and what you can afford to do. But a couple simple things to understand, and I'll show you one here really quickly if I can get to it. Let me see if I can pop that up for trying to get to this. No, well, I'll go back to this. I'll finish this off after the last slide. I'll show you this energy cost calculator. There's a lot of different spreadsheets you can use and a bunch of different things online, ranging from very simple ones that you can use to do a basic home energy audit on anything from an apartment to a whole house. And then they have some much more sophisticated programs and energy cost calculators, and one of the things, and that's what a building commissioner is going to do, especially when they're doing retro commissioning, they're going to compare all those energy conservation measures to see which ones are going to be more effective. For a small home weatherization project, you probably won't get into building energy modeling and looking at the difference between cost of operation of air handlers and energy usage of pumps and fan motors. But when we start talking about commercial buildings, all of those things start to add up, and having a pretty sophisticated energy cost calculator allows you to look at one measure over another. So you can see, if this one cost me $1,000 to install, how much am I going to get back out of it over a period of time, versus this one that cost me $2,000. And so you can see which one costs more or costs less. A couple other ways that sometimes people look at it are just simple payback. And the simple payback is calculated just in what it costs you to perform that, and whether that's the cost to air seal the house, do a bunch of caulking, versus how much it's going to save you per year, or what it's going to cost you to replace the furnace versus how much it's going to save you per year. And you can calculate that in several different ways. So simple payback, if you're looking at doing some energy conservation measures and you're going to spend $500 on them and you're going to save $75 a year, you'll hear that in simple payback, and the payback is 6.7 years. When it comes to weatherization and home energy audits and dealing with homeowners and actually selling them on weatherization, one of the number one things to know before you try to go in there and pitch to them what you're going to do to their house is, how long do they plan on living there? Because if they plan on living there for 2 years or 3 years, things that have a 10-year payback probably aren't going to register for them, and they're not going to be interested in them. The other way to look at it, and this is where the numbers start to make much more sense, is look at return on investment. So how much money am I going to get back on that initial investment? And so calculate your savings per year divided by the total investment. So the same energy improvement investment of $500 might not look as attractive with a 6.7-year payback, but it's got a 15% return on investment. So they could put that $500 in the bank and maybe make 0.75% or 1% on it, or they can put the $500 in their house and make 15% on it. So a little bit of semantics, but it's a great way to be able to frame the conversation, especially if you're talking to homeowners or building owners about energy investment. And then the last thing, just pick the low-hanging fruit. And this chart, we won't go through everything on this chart, but envision all that you do sort of as the pyramid, and the low-hanging fruit on the bottom are kind of very easy things that you can do. They're low cost, they're no cost, they're very simple, but they still offer a return. And then as you move up the pyramid, things become more expensive, and may or may not give you the same amount of return for the investment. So, and think of this concept when you're thinking about what you want to do with your project and the things that you want to put together for your weatherization plan. Because you could easily go in there, and I'm not sure any of the things on the upper third of it you could do with a $500 budget, but you could shoot your $500 budget pretty quickly on just one energy improvement item. Is that going to give you the best return on your investment? So look for those things that are near the bottom of that pyramid and go for the low-hanging fruit first before you get into the other ones. Let me see if I can, yeah, there we go. Just wanted to bring this up really quickly so you can see it. This is just one example of a energy cost calculator, and I can link this. I'll put this on Moodle so I can link this, and you can start it, and you input a few things. This one actually asks you some questions, and you can input your local utility and the cost per therm and your cost per kilowatt hour, and then basically just going through and looking room by room at all of your appliances and all of your fixtures So everything from the television to the DVR, and they give you standby watts, and then you put in your daily, hourly use. It'll calculate your energy cost per day, and then it'll chart out your daily, weekly, monthly. And it's actually not a bad thing to do if you want to do it. Just go through your own house and go through all the things that you have in there, and then it'll give you sort of a room by room consumption of what you have. But this is a fairly simple tool, but it's a great one when you're looking at trying to examine total energy use and trying to evaluate energy conservation measures one over another. You can see where the energy is getting used. Any other thoughts, questions, comments? Just too much excitement for one day and we should wrap it up? Gary says yes. All right. Let me know if anybody has any other questions on the project. The midterm, Friday, 11:15, we have our project site visit for field reps. And other than that, I won't see some of you till after break, so have a good break.